Hi viewers, welcome to Lemma Solution. Today you are going to see about power factor correction using SEPIC Converter, and also in this video you are going to see about the open loop control and the closed loop control for power factor correction. This is a model for open loop control. It consists of source voltage, that means AC voltage, and diode bridge rectifier, and then this is known as SEPIC converter, and this is flow. And this SEPIC converter going to be controlled in the manner of open loop. And then here we are going to provide 0.3 duty cycle, and here you can measure the source voltage and source current, and here you can measure the load voltage and load current. Here we are using the diode voltage with the load that going to act as a nonlinear load. What will be happen? The source current naturally going to be non-sinusoidal because of the nonlinear load. That means it will draw more reactive power from the source. So because of that, the source current going to be non-sinusoidal. So I'm going to simulate this model in open loop. We will see the results. So here you can see that this is the result of source voltage and source current and load voltage and load current. So here we are not control the load voltage, and also we are not control the source current. Yes, it will be operated in open loop. So that's why the source current nature is non-sinusoidal, and also we are not regulate the output voltage because it is going to be operated in the open loop. Next, we are going to see the THT of the source current. Further, go to FFT analysis and then go to source current. I'm going to analyze for a single cycle. So here you can see that we are getting around 66.24%. That means normally as per IEEE IEC standard, this would be less than 5%. Source current should be less than 5%. Then only the power factor also going to be near up to unity. But here you can see that the THT is around 66.2%. We need to improve that. That means you have to reduce the THT as well as you have to improve the power factor, because from that source voltage and source current you can see that both are not in phase. So that means because of that load draws load, and the diode which rectifier draws more reactive power from the source. So this is a problem. In order to avoid this problem, we go for closed loop control. The same circuit here we are going to use closed loop voltage and the current control. We are having two loops, outer loop and inner loop. Outer loop we are going to use voltage controller concept. Inner loop we are going to use current controller concept. Here you have to measure the load voltage, and when we compare with the reference voltage, and it when we process via PI controller, the PI controller will be generate the reference current in the form of DC. So and then it will need to be converted into AC form. Further we need to measure the input AC voltage. So from there you have to find out the unit voltage vector template that going to be multiplied with that reference current from the PA controller. Here you have the reference current in the form of AC, and then you have to compare this reference current with this current, diode rectifier current, and it going to be processed via again PA controller, and it going to be processed via PWM generator, and going to be generate the pulse for this IGBT in order to make the source current sinusoidal, and also increase the power factor of the system, and also reduce the THT of the source current. This is a closed loop control of power factor correction using SEPIC converter. Let me check the result of this system. I'm going to simulate this model. Now you can see that the nature of source current. The source current goes to sinusoidal, and then you can see the response of the load voltage. It when we made it around 100 volt, because here you can see that we are provided the reference voltage we have provided here is 100. It maintained at 100. And also you can see that the load current is maintained at around 2 amps. So here you can see that the source voltage and source current having in phase. Both are in phase. That means the power factor is almost unity. So next you have to check the THT of the source current. Here I'm going to check the THT. Here you can see the THT is around 3.72%. When we are not using closed loop control, when we are using open loop control, the THT is around 66%. When go with the closed loop control, like outer and inner loop control concept, that means dual loop control concept, so you can see that the THT is almost reduced to 3.72%, and also it obey the standard of IEEE and IEC for that source current THT. And also here you can see that the source current and the source voltage are both are in phase. That means if both are in phase means the power factor also almost improved to the unit. So this is a working of power factor correction using SEPIC converter with the D loop control. Thanks for watching our videos. Kindly subscribe our channel and also hit bell icon for notification about upcoming videos. Thank you so much. Bye bye.